In this video, we'll explore what serial monitor is, as well as how it can be used in data monitoring and debugging. We'll also look at how we can connect and read values from analog devices. Let's get started. Serial monitor is a window built into the Arduino software, or IDE for short. There are two options found in the Tools menu. Here we can see Serial Monitor and Serial Plotter. These windows are used to display data generated from the microcontroller board. Before we can see any data arrive on this screen, we'll first need to create a code that sends data from the board, such as the Arduino Uno, and transmits it out via the USB port. Let's open our IDE software. Let's start with our minimum program. Minus the two comments. As sending data out from the microcontroller requires physical ports, we will need to set them up on the void setup area of our blank program. We can simply type serial.begin, with only S as a capital. This is followed by open bracket 9600 close bracket. Like so. Basically we are turning the serial transmit and receive ports on, and this is set to a 9600 bits per second transfer speed. This may sound complicated, but essentially we can set various speeds. When the microcontroller transmits, it will pause until it's finished. We can use faster transmit speeds to get the job done faster. 9600 is fine for now, but both ends need to be set the same value. We will set the speed on the computer later. Now let's make something to transmit. Inside the void loop, type serial.println. Here we have a capital S, with all the rest lowercase. Then open bracket, and we'll type in speech mark hello, I am loading speech mark. Then we'll enter a delay of 2000 meters s or 2 seconds. Let's upload this to the board. There we go. Now we'll click Tools, and Serial Monitor. We need to make sure the value down here matches the value we've programmed into the Arduino. Once set, we are receiving the text-based words of hello. I'm loading at a rate of 1 every 2 seconds. When we entered serial.println, the ln on the end of print means, new line, let's delete it, and have just serial.print, speech mark hello, I am loading speech mark. Upload it. Sometime we need to close and reopen Serial Monitor. Sometimes, having Serial Monitor open could prevent the microcontroller reprogramming. If that's the case, close it down and reopen it later. Or press the restart button on the board. See how the same text is transmitted to the monitor, but now it runs left to right across the console. It's probably better to include the ln. Let's put it back in. iReality, we would only want our fancy gadget to say that it's loading one. Let's move this line into the setup area of the code. Simple drag over it, and move it up here by clicking and holding. Great, let's upload that to the board. There we go. Now we only get this text message transmitted once. Now let's get some other data transmitted. We are going to make two variables. One called countup and a second called countdown. We will use an int for now. Heads up, an int is a type of storage area, but we will do a whole video on that soon. For now, well, just type int countup equals 0. And int countdown equals 1000. These must go before the void setup. For now, we'll leave our serial printed text message in setup. Let's enter in the void loop serial.print open bracket countup close bracket. And then serial.println open bracket countdown close bracket. We'll also leave the 2000 meters s delay. Let's upload and see it. but you can see the numbers are displaying left to right. Let's add some ln to the code to make these values display from top to bottom. We'll re-upload and check it works as desired. There we have it. The values are now displaying from top to bottom, each value on a new line. I think this is easier to read. Right. So we now have our text message transmitted once. Then we have the value of count up and count down transmitted every 2 seconds. But the numbers are staying the same. Let's manipulate these values doing some simple math. At the start of the loop, let's enter in count up equals count up plus 1, and then count down. This is 2 different ways of achieving the same things. With count up, we make the value of count up equal whatever the current value of count up is, plus 1. We could of course use the negative symbol to subtract 1, or use a different value other than 1. With count down we use a double minus symbol. This is decrement, and a quicker way of typing out subtract 1. Using a double plus symbol would result in a increment, which is addition of 1. Let's upload it. Again, we see our text message sent once, followed by our 2 variable values being displayed. One is counting up, the other counting down. We could adjust anything at this point. For example, the speed or rate at which these values are displayed and recalculated. We could even add text in front of each like this. We follow the same format as our text above using the speech marks. If we want the items displayed on the same line, we don't add the ln. We add the ln each time we want a new line of text. So we have a ln here, and ln here. Note the space here at the end of the text before the speech mark. If we left this out, we would have no space between the text and the value. One last example for now. Our microcontroller has a basic built-in timer circuit. We cannot use it for reliable date and time, such as hours, minutes and seconds. If the power is removed, it will reset to 0, but we can use it to time events such as how long has it been since a button was pressed. To do this we call a function called millis. Millis will return a value equal to how many milliseconds have passed since the device was powered on. It resets to 0 every time the power is removed. It will also overflow, or return to 0 every 49 days as the maximum value that can be stored in memory is reached. We cannot simply send this milli value out to the serial port. First we need to save it into a variable. Let's make one called timer int timer equals 0 semicolon. Now in the loop, we'll enter timer equals millis open close bracket semicolon. This line basically makes the timer variable equal the current value of millis. We'll also change our delay to 1000 now. We also have to add a line of code that will transmit the timer value out on the serial port to the PC console. We will include the ln so it is on a new line each time. Then upload. Here we can see the value of milliseconds since powering up the board. In this last example, we will connect a variable resistor to an analog port. An analog port is a special port on a microcontroller designed to read a varying voltage value between 0 and 5 volts. The value is read in increments and in turn these increments are handled by the microcontroller as numerical values. As standard, the Arduino Uno has 1024 increments. 0 volts will return a value of 0 while a voltage level of 5 volts will return 1023. We will use a variable resistor to provide the varying voltage level. This device has 3 pins. The center pin is connected to a wiper that physically slides along a resistive material. Each end of this resistor material is connected to the other pins. If we turn the shaft towards one of these pins, the resistance value changes. Let's connect one side to ground, and the other side to 5 volts. The center pin will be connected to analog 0, labeled A0. Here we use some F to M DuPont connectors, or we could solder some solid cord wire to the resistor pins. Unfortunately, it won't connect directly to the board. Once the wire is attached, we connect the first pin of the resistor to the board's 5-volt pin, the middle pin to A0, and the third pin to ground. We need to modify our code to make this work. Let's pretend this variable resistor is a sensor. We'll define the pin as #define sensor pin A0. Then we need a variable to save the returned value int. So int pin value equals 0. We have our serial setup already in setup. Then in our loop, we'll enter pin value equals analog read sensor pin. Make sure to match the text case. Then serial.println pin value. We should keep a delay as sending data out too quickly can cause issues. OK, let's upload and see what it does. We should be seeing a value somewhere between 0 and 1023. If we turn the shaft on the variable resistor, we should be able to see the value change. If we rotate towards the ground pin, we should see the value drop to 0. If we rotate it the other way, it should increase to a maximum of 1023. This is a really useful sensor for a number of jobs. Finally, I am going to show you what serial plotter does. Let's modify our code so that it only sends out the analog value to the serial port. The quickest way to do this is to simply comment out the lines we don't want using 2 forward slashes. This way we can easily get them back if needed. Comment out all the serial prints other than the one with pin value. Upload. Now open Serial Plotter from the Tools menu. We can see a line is plotted, but it is very slow to update. As I turn the shaft on the variable resistor, a line is traced out. Let's change our delay value to something small like 10 milliseconds. Re-upload, and we can now see the graph line is updated much more fluidly. It seems really responsive. This is a great way to see a graphical representation of a sensor or other changing value. When a chef comes up with a great meal, I bet you they write down the exact ingredients so they can reliably replicate it. As a programmer of the future, you should do the same. Save your example programs with easy-to-remember names so that they can be used in the future. This will speed up the time it takes to create new programs. That's it for now. Make sure to subscribe for the next video. Bye for now.